Hello, my name is Damon Rocha, and this is my GPE104 Week 4 project. So I'm going to, in this video, I'm going to cover arrays, array functions, for each loops, randomness, physics, sphere overlap actors, direct and inverse proportions, some other nodes in Unreal, and then just give an overview of my board's website and where I actually posted this project so people can try it out. So let's start with arrays. So this week I was able to use arrays in a few components, but I'll start here. So in this exploder component, I am getting the actors that overlap this sphere and adding them to this actors to push array. And then I'm taking these actors, simulating physics on those actors, and then pushing them away. And then if they have a health class damaging them. I'm not going to go into all that right now, but when I get to physics, I'll come back to this and show how I'm pushing them away. And then another place I'm using arrays is in this time portal component. So this time portal component, whenever this usability is fired, when user presses F, we're going to set the closest portal. And the way to do that is to get this portal's array, which is set in this begin play, which the portal's array is all actors of class BP portal. So it's just getting all the time portals in the world and adding it to this portal's array, or setting that array of actors as this portal's array. And from there, we're going to loop through that portal's array using for each loop, which is actually the next thing after next. Let's go right now. So for each loop, and what we're going to do in this for each loop is compare the minimum distance to this the distance of the first item, and then just goes from there. If it's less than that, it'll set that as a minimum distance into the new closest. Otherwise, it just keeps looping through until the end of all of the items in the portal's array. And this portal's array is just a list of actors in the world. So it just lets you, instead of having to reference each portal individually, it has like a data structure that holds all the portals together in one place. And let's move back onto array functions. So I couldn't find any great place to use array functions. So I just kind of thought in the future, if I wanted to teleport anyone actors besides the player character, I'd use this actors to teleport array that I created in the actual portal. So in this portal component, it's going to teleport the actor, which is a class or a function I created that just takes the actor and moves it to the connected portal from the portal that's at. But what I'm doing here is getting this actors to teleport array and adding this actor to there. And then for now, all it is just that. It just adds it to this array. Then we go through the portal, toggles the old portal off, there's delay, and then it would remove the actor we just added to that array. So in essence, this array is never going to really have something in it, but in the future, I could be like, wait till a certain amount of actors are in the actors to teleport and then teleport, or something like that, like have a teleport goal or some type of portal you have to bring stuff to. I haven't thought it out yet, but that's where I'm going with those two nodes. From there, let's go back to the exploder and cover physics. So we're simulating physics on any actors to push in this grenade's explosion radius, as long as they have the static mesh component. So in this push actors away function, we're going to take the target actor and their mesh. We're going to get a vector that points away from the grenade to give a vector that we're going to use as the impulse. And then we're going to get the force of that force by distance, which is going into those inverse proportions. So I'll cover that in a little bit. So this function just in essence gets the force that the grenade is going to impose on the actor. So we are going to get the force and multiply that by this vector in the direction of the vector away from source to give us the impulse, which is just like a push. And we're doing it at the location of the impulse is from the location of the grenade itself. And so this exploder component actually is activated in this grenade projectile, which is used in this grenade thrower. So all it does is once you press Q, makes a transform of the, based off of the direction the player's facing, and spawns one of these grenades. But that's out of what we're covering right now. So we go back to this. So on the other side of physics, this is a physics actor I created. It's just a barrel that has nothing else other than we're just setting simulate physics. And it is a physics actor. And the simulate physics isn't set beforehand. It's just once the begin play is run, we're setting the simulating physics on this barrel. So it'll actually act like a physics actor, and you could push it around, kick it, hit it, whatever. And it's good for physics. I did want to cover randomness. So I found a few good places to put this randomness. So the first one is the grenade's explosion time, like how long it lives. So I have a min and a max that can be set by the designers. I just put it at 0 and 3. So the grenade's going to, after it is spawned, it's going to blow up at any time between 0 and 3 seconds using this delay node, which is just saying, hey, wait for whatever this float is. And then we're going to run that explode function in the exploder component. And speaking of that, let's hop back over there to cover the sphere overlap and the proportions. So jump back to the sphere overlap. So the sphere overlap actors is going to get the owner of the exploder component, which is grenade, and get that location, and set this as a sphere center. And from there, it's going to have a sphere out to this exploding of this explosion radius, which is again can be set by the designers or whoever's using this component. And it's going to just find physics bodies, because I was having it run into errors when I was using world dynamic or world static, but physics bodies seem to work pretty consistent. And this is just going to give us an array of actors that we're saving to this actors to push. We already kind of talked about that earlier, just looping through all that, setting simulate physics, and pushing objects away. So now for direct and inverse proportions. Some inverse proportions I used, which is just like you take when the distance gets smaller, the force gets bigger. When the distance gets larger, the force gets smaller, or vice versa. I did the same thing with damage. When the distance is closer, when the distance is smaller, the damage is larger. When the distance is larger, the damage is smaller. I don't really need to cover both of these because they're fairly similar. I did want to cover this one though because I use this random float in range. So here we're getting the distance to the other actor from the grenade. Then we're going to see if that is greater than the explosion radius. And I did this because I was seeing some issues with it trying to damage actors actually outside of this radius, and it was coming back as negative. So then we're getting that distance, dividing it by the explosion radius to get a ratio, and then subtracting that from 1. And that gives us that inverse proportionality. We're going to then multiply that by the explosion damage, And then I wanted to add some randomness into this. So I wanted to then multiply that, divide that by divide this explosion damage by 1.25 as a random float min, and let this value here that comes out of this multiplier as the max. So it adds a little more variability to the grenades. I figured that's kind of on point because it's an explosion, so it's unpredictable. So like it shouldn't hurt the same way each time. And then force is it's a little simpler, but pretty much the same thing. You're just getting the distance, and then dividing that by the explosion radius to get a ratio, subtracting 1 to get that inverse proportion, and then multiplying that by the force to get force. So if it's 0, then this explosion force is going to be like if it's 200, it's going to be 200. But if it's like 0.9, it'll be 0.1 of this. Or if it's 1, then the explosion force would be 0. And I did miss one of the randomness that I used because we got the randomness here. And I think I might have skipped the other one. So let's real quick. Oh, and we did the one in the delay, but we missed this. So I also used this random bullet weight that added a 90% chance of your bullets hitting the enemy, but there is a 10% chance that this will return false and then your bullet will miss. So with this first person projectile, it's not going to always hit, but for the most part it will. And then for direct proportion, doing that in this portal. So in teleport actor, let me see, it might not actually be in this portal. Let me look a little further. So we're teleporting. Okay, yeah, so it's right here. And I actually should probably collapse this into a function, but I ran out of time to do that. So something for next week. I'm getting the last updated velocity of the character's movement, and then getting their max speed to get a ratio of their speed to their max speed. And then I'm directly multiplying that by this teleport push. So if this is a 1-to-1, then we're going to get 1, and then we're going to add that impulse. We're going to multiply this velocity vector by this teleport push and add it as an impulse to the character movement. If this was like closer to 0, then they're going to move pretty close to the speed they went through. And all this does is when you go through the teleport portal, it just pushes you through a little faster when you come out the other side. And here's flip-flop. So here, once this portal is toggled, which is just hitting F, anytime that the player hits F, this portal will jump back and forth. And that is in this time portal when we're getting this closest portal. So it sets the closest portal, and then we'll just use the toggle portal event anytime the usability, which is the F key. So here, the first time it's going to turn the portal on, turn the portal off, and it'll just go back and forth between that. And I had it set different materials so you could tell that it was on or off. And then I've shown delay a few times, have that there. And then a sequence, which just, actually I think the enemy, yeah, here's a good spot for the sequence. So the sequence node, it more or less runs these like they're connected one after the other. It's just an easy way to look at it. So here we're going to rotate to the player first, and shoot at the player, move to the player, and every time it gets back to the sequence node, it's going to go through that. I didn't find a place to do once or do n. I tried a few spots, but it didn't make a whole lot of sense with what I have so far. One thing I'm thinking of is at the end of the game, have like a place you have to go back to, and you can only allow you to hit that spot once, or have like another spot. I think actually one spot we can put it that I just thought of is in this BP killed component. So I only want this to be able to kill them once, and I don't want them to get more score. If like for some, I don't want this to run multiple times. So what I could do is here after this game mode on this on enemy killed, I can have this as a do once, so it only runs through one time when the person kills an enemy instead of it accidentally going through over and over again. I had something like that happen before, and I think I ended up adding a bunch of if checks, but that code doesn't exist now, so I didn't have to worry about it. But that's one place I can get the do once, and that is it for the changes I made. You can just go to prove that it all works, and then go through my other stuff. All right, so the score will be random, 14 on that guy's death, and I got 16 on that one. And then these are the portals. It'll get the closest one, so if I hit F here, it's the closest portal, so I'll switch it back on and off, but it's not going to mess with that one, or there's one over there. And Q now spawns these little grenades that blows up and sets an impulse to those actors, and it works on the enemies too. And I think it's going to be hard to show the shooting is random, so I'm not going to worry about that. We got the explosion, we got the score being random. I think that's it. I'll just hop through this real quick. I think next week I want to make as like part of the last bits of this project is make these guys smarter, because at this point you got to get pretty close. But if I set it too much, they will get you as soon as you come out of the portal. Oh, I wanted to show that impulse. So, and then the direct versus indirect. So let's go back through here. And so over here has a little bit, but right here it throws it much more. So it just shows that damage versus distance. And then if I run through this instead, I kind of get shot through with that direct proportion impulse. I find it hard to do on some of the smaller ones, but the big ones make it a little easier. And yeah, that's it. Let's go over what I have for my boards real quick. So here is my boards website I created on Weebly. I just added the objectives and have my game right here. And I was able to get a build of my game on itch.io and started getting the code in Bitbucket. I was running into some issues, but I should be able to finish this up by the end of next week. And then I listed the rest of the objectives. And then here is the game page for the game. And that's about it. Thank you very much.